Why do zebras have stripes instead of being one solid color? A zebra should be easy to catch. Imagine standing in the open African savanna wearing the boldest pattern you can think of, thick black and white stripes that can be seen from far away. If you're a prey animal surrounded by lions, that sounds like a terrible survival strategy. So why would evolution paint a horse in the most eye-catching design imaginable? For more than 150 years, scientists argued over that question. Some thought the stripes helped zebras disappear. Others believed they confused predators or kept the animals cool under the blazing African sun. But the answer that has gained the strongest scientific support today points to an enemy most people barely notice. Not lions, not cheetahs, tiny blood-sucking flies. At first, the camouflage idea seemed obvious. After all, many animals blend into their surroundings. Deer have brown coats, Arctic foxes turn white in winter. Countless species survive by becoming harder to see. But zebras seem to do exactly the opposite. Their stripes stand out against dry grass, open plains, and dusty landscapes. To human eyes, they're impossible to miss. So perhaps the stripes weren't hiding individual zebras. Maybe they confused predators when the herd ran together. Picture dozens of striped bodies sprinting side by side. The moving lines seem to merge into a constantly shifting pattern. Some early researchers suggested that this motion dazzle made it difficult for a lion to focus on one target. It was an elegant idea. The problem was evidence. As scientists studied lion behavior more carefully, they found that lions are remarkably successful hunters of zebras. At the distances where lions usually detect prey, the stripes don't seem to fool them nearly as much as people once imagined. Predator confusion may provide a small advantage when an entire herd is moving, but it doesn't explain why every zebra carries stripes across almost its entire body. Then another possibility emerged. Maybe the stripes worked like built-in air conditioning. Because black surfaces absorb more sunlight than white ones, some researchers proposed that alternating black and white stripes created tiny temperature differences. These differences might generate small air currents close to the skin, helping zebras stay cooler under the hot African sun. Again, the idea sounded reasonable. And again, scientists tested it. Some experiments found small temperature effects. Others found little evidence that the cooling was strong enough to explain the evolution of such dramatic patterns. Cooling may still play a role, but it doesn't appear to be the main reason zebras evolved stripes. Scientists also explored whether the patterns helped zebras recognize one another. Just as every person's fingerprint is unique, every zebra's stripe pattern is slightly different. Mothers and foals may use these distinctive markings to identify each other. The stripes might even help communication within herds. That's possible, but unique identification alone doesn't explain why natural selection would create such bold black and white coats in the first place. One by one, the most famous explanations became less convincing. Instead of relying on intuition, researchers began asking a different question. What if everyone had been looking at the wrong enemy? Now imagine the African savanna from the horseflies' point of view. Horseflies don't just cause itchy bites, they feed on blood. They can transmit diseases and parasites. Every successful bite steals blood, stresses an animal, and increases the chance of infection. For large animals living outside every day, thousands of bites over a lifetime can become a serious evolutionary problem. If even a small change reduced those attacks, animals carrying that trait could survive a little better and produce more offspring.
That's exactly the kind of advantage evolution can amplify over countless generations. So, scientists designed clever experiments. They compared real zebras with horses. They placed striped rugs over horses. They built artificial models painted with different patterns. Some researchers even painted zebra-like stripes directly onto cattle. Then they watched. The results were surprising. Horseflies approached zebras almost as often as they approached horses. The stripes didn't seem to scare the insects away. The real surprise happened during the final moments. Using high-speed cameras, scientists discovered that flies often flew toward zebras normally, but struggled during the last split second before landing. Instead of making smooth landings, many suddenly pulled away, misjudged the surface, or collided awkwardly before flying off again. They came close, they just couldn't stick the landing. Exactly why this happens is still being investigated. Researchers think the bold black and white pattern somehow interferes with the fly's visual system during the precise movements needed for landing. But the exact optical mechanism remains an active area of research. What matters is the outcome. Fewer successful landings means fewer bites, and fewer bites means less blood loss, fewer parasites, and lower risk of disease. Even more convincing, the same effect appeared in animals that weren't naturally striped. When scientists painted zebra-like stripes onto cattle, those cows received significantly fewer biting flies than unpainted cows standing nearby. The cows hadn't changed species, only their pattern had changed. That simple experiment transformed the debate. Suddenly, the stripes weren't just beautiful markings, they were functioning like biological insect protection. Comparisons across Africa revealed another clue. The strongest zebra striping tends to occur in regions where biting flies are especially common. That geographic overlap is exactly what evolutionary biologists would expect if parasites helped drive the evolution of stripes. Today, reducing attacks from biting flies is considered the best supported explanation for why zebras evolved their famous pattern. Notice the wording, though, best supported, not completely proven. Science rarely deals in absolute certainty. Researchers continue testing new ideas because evolution is rarely driven by a single factor. In fact, some of those earlier explanations may still contribute. Small cooling effects might offer additional benefits. Moving herds may sometimes make it slightly harder for predators to single out an individual. Distinct stripe patterns may help zebras recognize one another. These possibilities aren't necessarily wrong. They simply don't have as much supporting evidence as the fly deterrence explanation. And that's where the mystery becomes even more fascinating. If stripes work so well against biting flies, why don't wildebeest have them? Why not buffalo? Why not antelope? All of these animals face biting insects too. Scientists still don't have a complete answer. Different species inherited different evolutionary histories. They live in different environments, have different body shapes, behaviors, and coats. Evolution doesn't search for the perfect solution. It works with whatever traits are already available in each lineage. That's why no single explanation accounts for every stripe on every zebra. Why are some stripes narrow while others are wide? Why do different zebra species have different patterns? Why do certain body regions have stronger striping than others? Those questions are still being explored. Ironically, the more scientists learned about zebra stripes, the more new mysteries appeared. Perhaps that's the most surprising lesson of all. When we look at a zebra, our attention naturally gets drawn to lions racing across the grass. Evolution may have been paying far more attention to insects no bigger than your thumb. One of the most recognizable patterns in the animal kingdom may exist not because it fooled giant predators, but because it made life just a little harder for tiny flying parasites. Nature often works that way. The biggest stories are sometimes written by the smallest characters. And the next time you see a zebra's striking black and white coat, you might not see camouflage or decoration anymore. You might see millions of years of quiet evolutionary battles between a remarkable animal and the tiny insects that shaped one of Earth's most iconic designs. If you enjoy uncovering the hidden science behind everyday mysteries, subscribe to CurioLogic. There's always another ordinary question hiding an extraordinary answer.